So for today, for us, for this 133 side of things, we have three things to accomplish. Um, one of them is to put Chapter 7 to rest, and we'll do that by working through the Chapter 7 project and the Chapter 7 review worksheet. And then work through the 1-4 worksheet. So then Monday and Wednesday, oh, look at this. I've left these dates in here. I got to fix that. So Monday and Wednesday of next week, we're going to get through Chapter 8. And I just want to warn you all about Chapter 8. I did it for the night class, but I think I forgot to do it for you all. Chapter 8 is heavy theory. So it's the why that allows us to do everything we do in chapters 9, 10, and 11. And lots of times for students, theory is difficult. So I just want to encourage you that we're laying the groundwork for why. There's a few key things that you need to pick out from chapter 8. But don't get overly stressed about it. All right, it's theory. So you'll work on that tomorrow. I think for or whenever you do that. I think we should start with the Chapter 7 project. So yeah, today it's the Chapter 7 project, which is all digital, and then the Chapter 7 review, which is page something or another. I can get us that page. Chapter 7 review. There we go. Nope. Yep. So page 631, and then the 1-4 worksheet, which I think is worksheet number 2, which is page 468 and 469. So let's start with the project, because it gets us back into StatCrunch, and everyone loves projects. So I don't want to like Christmas morning, keep you waiting to open those gifts over and over and over, hours and hours and hours. We don't have to have our coffee and our cinnamon rolls or whatever. Let's just get right to it. Let's just tear open those gifts. So the Chapter 7 project is on day 16 module, the 1024, which remember we didn't get to it yesterday, or whatever day that was. So click that, and as usual, you're going to go to the top and do the open the Google link. It's been a long time since we've done that. So we'll click this link. And as a reminder, we need to download this as a Word document to our computer. Otherwise, you can't do anything. So you're going to do File, Download, Microsoft Word document. That way we can edit things and copy stuff from StatCrunch into here. There's that. Do you remember when we did that like 17 weeks ago? And then there's a home run 2017 data set in StatCrunch. There's a link here. So if you click that link, it'll open the data set in StatCrunch, so you don't have to search for it. If you haven't signed in yet, you'll have to click here and sign in so that you have the data set. So let me pause here and let's make sure we're all on the same page, that everyone has the Word document downloaded from the Google Docs document and has the data set opened in StatCrunch. So maybe when you've got all those things, tell me, like I got it in the chat, or a mic, or a whatever.
I have it. I'm just trying to figure out how to get it all on one screen. Yeah,
that's a challenge. What we need is like 3 monitors, and then you could have each monitor, me on one, StatCrunch on another, Word on another. But
in my science course last semester, many of the students had multiple monitors, and they were like, you guys, you need multiple monitors. What?
$500 and you got it, whatever. Each monitor is maybe 100, 150. Oh, you buy those like $1,000 ones that are like curved a little bit for the gaming. I don't know. Laura, Reagan, Kayla, Taylor,
Yeah.
y'all good? Y'all good?
I'm that split screen. I got you on one and my Stat Crunch on the other, and I'm gonna have to click back and forth between Microsoft Word because I always gotta watch you before I do it.
Understood. Understood. I just
I'm
don't
ready.
want to rush ahead. I just want to make sure we're there. Why is this
Reagan
now?
said she
I
got
have
it.
like a half screen of Stat Crunch. I mean, that's really all I can do right now to view it all. So
Cool.
hopefully,
So
hopefully it'll all go.
let's start. So let's all start in the Word document. So I'll just make this full screen. So all you see on my screen is the Word document, and we're just going to read what we're going to do. We have, when you click this link, you can, I guess you can click it here, or we clicked it from there. So we all have the data set. And notice the first thing we're going to do is draw a relative frequency histogram of the home run distances. And then we're told what to use as the start value and the width, and we're going to paste that in here. Okay, so I'm now going to go to StatCrunch, and we're going to do that. So I will now make StatCrunch full screen. We want the relative frequency histogram. So I believe we go to Graph and Histogram. I'll pause there for a second. Yeah. And you want to click the distance from the select columns spot. We were told, oh, and we want relative frequency. So under type, make sure you select relative frequency. We were told to start at, so the bins here, under the bins option, we're going to start at 310, and we wanted a width of 20. So I'll pause there. So this is this is everything you need to do from the histogram menu. Anyone need me to redo it?
With this 20, you said, right?
Correct. Width of 20.
Got it.
Nice. So compute, there it is. Ooh, ooh, isn't that beautiful? Anyone want to comment on the shape of this histogram?
Normal,
It's beautiful, symmetric.
bell curve, symmetric.
Normal, symmetric, bell curve. Yeah, awesome. So we're going to copy and paste this into the Word document. So if you recall, I think the best way for everyone to do it was go to Options, Copy, and it creates this new thing. And then you right-clicked on the new image and selected Copy Image. Then you click into your Word document. Swoop. You right-click in there and you paste. And it should look something like this.
I'm sorry, I had to walk away real quick. Can you show me real quick how to get the graph again?
Most definitely, not a problem. So we did graph, histogram. Misty, did I notice that you just came in? Do you know where we're at with everything?
No, I don't, but yeah, I did just come in.
Okay, so let me show you where we're at.
Okay.
We're doing the Chapter 7 project.
Okay.
So do you know where to find it under the modules?
Yeah.
It's like 1024. We did this link to get to the Google document. And then remember, you have to download these things. So this opens up and we did File, Download, Microsoft Word.
Yep.
Awesome. And then we also clicked the StatCrunch link here.
Okay.
That got us to this menu. And if you haven't signed in, you'll have to sign in to be able to do stuff.
Okay. I'm signing in now.
Awesome. And we're just doing number 1.
Okay, great. Thank you.
You are welcome. So Taylor, we selected distance. We changed the type to relative frequency. We set the bins to start at 310 and the width to be 20. we computed, and there was that beautiful normally distributed graph, approximately, right? Because these two bars aren't exactly the same, but whatevs. And then we did options and copy, so that it created this new image, and then right-clicked it, copied image, dumped it into Word. How's everyone doing? Any we all okay? Those of you that maybe already have it, did you type in your answer to letter B?
Yes.
I
Yes.
just said bell-shaped normal symmetric. Is that right?
Good. Yeah, it looks approximately normal. Yeah, excellent. That's
Oh,
exactly what we're
or
supposed
looks
to do.
approximately normal. Huh.
Awesome. How about B? It says this data set can be treated as a population. Why? Boy, let's look at this. This is the home runs for 2017. Now, I don't know if anyone knows what dates the Major League Baseball plays, but here's April 4 as the very last date, and here's October 1 as the very first date. That seems like the regular season, from my knowledge. So this is all the home runs hit in 2017. Does that help you understand why this is a population?
Because it's all the home runs for the whole season. Okay.
Yes, it's one particular season, all of them. Now, if we were interested in the home runs hit, oh, here it is up here, all home runs for 2017. If we were interested in like home runs of all time, then this would just be 1 year's sample. But I think we're just interested in the 2017 year. Cool. Do you all remember how to do the mean and standard deviation? It's been a while. Well, you did it on the midterm, right? And like, I don't think anyone got that question wrong in the midterm. If you've forgotten, you go to stat, summary stats. This is columns. We want just distance, and we want mean and help me. Which standard deviation? The standard dev or the unadjusted standard dev?
Unadjusted, because it's a population.
Oh, love it. You all are doing it. Okay, there it is. Hopefully we all got the same thing. And we got to copy this again. So remember, you do options, copy. Oh boy. So this is the one where you click inside and you have to select all. So you click and do Control A. Or you
Hang
can
on, I'm way behind. I'm
Oh,
just
okay.
getting in there. So can we back up, please?
Yeah.
So we're going into home runs, and then what are we doing? Right, we're doing this, the mean and the standard deviation.
Yes. So remember
So
summary
I do
stats.
summary stats, columns. Is it distance or is it everything?
We're just doing distance for this, I think, for this entire worksheet.
Mean and standard, it's unadjusted standard deviation.
Good.
Okay. All right, I'm good.
Cool. So then to copy it, this one's the more challenging one to do it. You have to like select it all. So I'm like left click, drag clicking. So it's that, or you can click in there and do Control A, and then right click and copy. And then that will dump that mean and standard deviation here. Just like that. Question. What two pieces of information did we need in order to calculate probabilities from a normal distribution? Probabilities of values being greater than or less than something.
I want to say it's the frequency, but I feel like that's wrong.
It's a good thought. So let me go down here so it's very clear what I'm asking. What did we need in order to calculate something like this?
The area.
We're gonna find the area, yeah,
The-
but we're gonna use StatCrunch to
The
calculate.
mean and everything.
Yeah, we needed the mean and the standard deviation. That's why we said, hey, go find this. Because we're about to use these two numbers to do a bunch of stuff, do a bunch of calculations. Let me pause here. Let's make sure everyone's on the same page. Has everyone got the mean and standard deviation in for number 3? Do we all have that down?
I'm still working on trying to copy and paste it. I can't get only the mean and standard deviation.
Let me help you there. So when you're in here with this, you have to just click mean, and then it deselects everything else.
Yep.
And then you have to control click unadjusted standard deviation.
All right, I have to undo everything I just did because I did the same thing.
I mean, it's fine if you have the other stuff. It's just distracting.
No, it takes, it's not right.
Fair, fair.
Oh man. It's like it's not working.
I know, and me too, so I feel like I'm holding you up, but I really want to get this right.
So you did summary stats columns, right? And you did distance. And what do you see here in the white box, in your white boxes?
Mine says just mean because I clicked just mean.
Okay, now scroll, while you're in here, scroll down without clicking.
Yep.
Till you see unadjusted. Put your finger on the control button and don't do anything yet.
Okay.
And then click. Wait, Taylor, do you have a Mac?
Yes.
Okay, you need to use the command button.
Okay. Okay, got it.
Nice. How about you, Peg? You got it?
Hang on. Okay, I have it. But what happened to me last time was when I just tried to copy the unadjusted standard deviation and the mean. Wow, this is different. It didn't transfer over. Okay, you guys, are you getting 25.636172 and then the mean is 400.27573?
Nailed it. Yep.
Okay, okay. So now I just have to figure out how to get this thing
So
over.
put your cursor, put your little mouse thing so it's inside the box. And
Okay,
put it so it's in the top left corner next to the S. Push your left mouse button and hold it and drag so you see that blue thing until it's dragged across everything, if that's the right word, or drugged across. I don't know, what is it? So it should look exactly like my screen where the
okay, hang on. I've got to come back to your screen.
Okay.
So you're you're just doing like you normally copy and paste. Is that what you're normally? Is that what
That's
we're
it.
doing?
But
All
you got
right,
to
hang on.
you got to drag across so everything's selected.
Okay, I
And then
got
I'm
this.
right
Now let me
clicking.
see. Control
Okay.
C. All right, I'm sorry to hold stuff up.
You're
I
okay.
just sometimes when you go between screens like this, it's like, oh my God, really? Okay, paste them. Where am I pasting it? Okay. Control V. Got it.
Okay. So now what we're going to do in number 4, we're going to compare the histogram to the normal curve that we're about to draw. So if you remember, histograms are discrete distributions. They're bars, right? So whatever. So now we're going to overlay on top of that histogram the normal curve. So we're going to get that histogram the same way we just did it. Go to Graph, Histogram, select Distance, put in your 310 for start, your 20 for width, make sure you have relative frequency as type, and then we're going to scroll down and there's this display options, and it says overlay display, and we want to overlay normal. Now I want to see how much mean we want to put in here. So then we're going to put in the mean and standard deviation we just had. And I'm going to say, let's use all the numbers.
Okay, can you just slow down a minute?
Mhm.
Just go slower. So overlay distribution is normal. And then now are we putting in the mean and standard deviations that you're just about?
That's the spot I'm at. Yep. So I'm just copying and pasting from in here, but you can type it, whichever you want.
We read out the numbers so I don't have to look because
Yep.
I've got so many windows.
You ready for the mean?
Yeah,
The mean is 400.27573.
right? Okay, and then the standard deviation. Now, if it's are we unadjusted right now because we're a population or are we not?
Mhm. Yep.
Okay,
And it doesn't,
so it doesn't matter, you just put it in where it is.
type it in because we know
Okay.
what it is. We know how we
Okay.
calculate.
Okay.
So it's 25.636172.
Yep, okay,
Now we got to add one more thing in here. We want to click the value above bar checkbox.
What part are you in, Eric? As you know, my daughter's really sick, so I
Okay.
had to go grab her really quick. So,
So we're doing the histogram again.
okay, graph,
just-
histogram. Okay,
The same stuff we did before with the relative frequency and the 310 and the 20 and the distance. And then we're now under options, you select normal for overlay distribution.
okay,
And then you're typing in the mean and the standard deviation that we found previously. And we used all the numbers.
okay. So, sorry, can you read those numbers again?
Yeah, definitely. So for the mean, it's 400.27573.
All right, I got both of them. You just pulled it up and I have a split screen. I'm ready.
Okay, hit
Thank you.
compute, y'all, and oh wait, did everyone click the value above bar checkbox?
yes.
Click that, hit compute. Oh, look at that.
It is really kind of cool and satisfying when you see the graph and stuff.
Yeah, isn't it?
Yes, it is for me. I like it.
So
As long as
there
it's
it is.
correct. As long as
Yeah,
I'm not-
right. So let's copy it. Same way we did it before. Go to options, copy, right click, copy image, smash that into your Word document.
So my graph doesn't have the decimals on it. I don't know where I went wrong.
I'm guessing you didn't click the value button. Here,
It,
let me I'm gonna paste this. and show
Eric,
you.
what were we supposed to put something in for the oh, just kidding, never mind, I figured it out.
So everyone's got distance, relative frequency, 310, 20. So you selected normal and put in your mean and standard deviation, right? Someone said they didn't have the values above.
that was me.
Okay, Misty, did you click this value above bar button?
I did, but I did not click the type. So it was just frequency.
Gotcha. That's it. Right. Cool. All
Okay.
right. So I'm about ready to turn you loose. I'm about to stop helping you. For B, you say whatever you want. Peg, you were like, hey, that's so satisfying, looks good, awesome, yes. For C, now notice it says relative frequency with which a home run distance between 350 and 389.9 feet is observed. So when we look up here, here's 350.
Hang on a minute. I'm sorry to backtrack, but I didn't get decimals either. I thought I got it right and I didn't.
You don't have the
Everything
complete-
looked perfect. And now I look at yours and you have decimals and I don't. So
So-
I know you explained it, but I was busy going back and forth between screens. Wow, I gotta tell you, I understand these guys with the need of 2 computer screens now.
right?
So
So
what
just
did I
go
do
back
wrong?
into the histogram thing, get back
Okay,
into
hang
that box and put everything in that you had.
All right, hang on. Okay, so histogram. We're doing distance. We're, oh, you know what I bet I didn't do? Relative frequency.
That'll do it.
Because when you said that, so what is it, 310 and 20?
Nailed it. Yep.
All right, hang on. Let me just make sure I get the right thing. No, I got the same thing.
Now,
All right, wait a minute.
did you select the value above bar checkbox down at the
No,
bottom?
no.
That's the reason.
Okay, so histogram, distance, relative frequency, 310, 20, sorry, you guys. Oh, value above bar. Compute. There we go. Although I don't have the red things that you have now. So what did I do wrong there? God, I did it so right the first time, I thought.
You got to select the overlay distribution button.
I thought, oh, and the value above bar?
Yep. Yep.
So it's normal?
Yep.
Wait a
I'm just
minute.
going to see what the chi-squared looks like. Oh, I don't know the degrees of freedom, so I'm not going to do that. What about the beta? Yeah, we can't do it. Gamma, that's a good one. Oh, these fun. Uniform. It's not uniform. Okay. So let's see. I'm struggling. I might need help from you all. It says relative for C, relative frequency between 350 and 389.9. Do you all agree that that's going to be 0.1? Or is it going to be 0.31? Do you see my dilemma?
No, I do not.
So here's 350, right? I'm looking at the graph I copied over. So 350 is here. The question is, where is 389.9? Let's see. The width is 20, right? So that means that this would be 370, and this would be 390, and this would be 410. How's everyone feeling about that thought?
That makes sense.
Okay. Okay.
That makes sense.
Okay, good. So if you think through because I really didn't know, and then I realized, oh, the width of these bars is 20.
So I think the 410 would be 420, right?
Well,
No,
if
no,
this
no. You're right. You're right.
okay. It's weird, right? Because they put the 400 in the middle.
Oh, the
of the bar.
400's in the middle. Oh,
Yeah.
Yeah. And it's not a useful number other than, yeah. Okay, so that means if we're saying 350 to 389, that is these two bars. So we're going to add together these two areas. Which gets us to 0.31. Now, if you think about what we've just done, we've calculated the probability of 350 x 389.9 and it's equal to this, and this is for a discrete distribution. We did it from a data set. These are exact values. In fact, I think we included the equal to sign. And the reason it's not actually discrete data, because the distance can be anything, but we treated it as discrete by turning it into this group data set. So we grouped all of the distances of the home runs to be 350 to 370 and 370 to 390. And we just counted how many are in between these. Okay, now, do you know how to calculate this area for the normal curve? So nope, now we're going to calculate it this way. Actually, this one's going to be rounded.
And when we put that into StatCrunch, we use like the 0 and the 1, or we
Ooh.
we put the standard deviation that we found. Okay.
Good. Okay, so we're gonna run over to StatCrunch. We're gonna go to Stat, Calculators, and Normal. And Reagan's made a great point. Do we use 0 and 1, or do we use something else? So the question is, did we use data value? Did we use z-scores, or did we use data values? And I think you all answered it already. We use data values. So what we got to put in here is this mean, 420.27573, and I'm going to use all the numbers. And this standard deviation, 25.636, blah, blah, blah. And I'm just Control-C and Control-V it in there. And then because it's a between, we'll click the between button. And we wanted 350 and 390. Let me pause there and make sure everyone's okay. All right. Okay, let's compute. Hey, look at that number. We're to copy this picture. We're to copy and paste this into the thing. So we'll do the same thing we did before. Options, copy. It creates a nice picture for us. Right click it, copy image. And we're going to paste that right here. Oh, I didn't want that one. Let's do this one. Notice that 0.31934065 is really close to the 0.31 we got from the relative frequency from the data set.
I'm still trying to get that on mine.
Talk to me. Which part?
So I just opened the normal calculator. So we're just putting in the mean that we did have.
Mm-hmm. Mm-hmm.
All right, let me click back and figure that out.
You want me to read it to you?
Yeah, that would be faster.
Nice. So the mean, tell me when
Right
you're ready.
there, 400 point. Okay, and then the between was the 3.
25.636172 for the unadjusted standard deviation.
Okay. And the lower was 360.
350.
Oh, 350.
And then we
390.
went up to 390. Nice.
Okay. Sorry, everybody.
You're okay. That's all right.
My life is busy over here.
Yeah. So Laura, you got it?
Yeah, I'm getting it over there right now.
Okay, awesome. Awesome. The copying part, whatever, right? Okay, so let's see. We said that. You've got the normal curve now with the actual thing. So this is our value right here, which is very similar to the number we had right here. Feels good. I would love to, what do you all think for E? When we compare these two values, if we use the histogram versus the normal model, how do you feel about that? What does it show us?
Could we say just that like we were really close just from looking at it, just looking at the graph, but we didn't get like the exact same number?
Yeah. So the most correct one, I think, is probably the 0.31 because that's the raw data. But our normal distribution, we noted that this histogram was approximately normal, right? Like it's pretty stinking close. And so we then calculated the exact percent of values between 350 and 389.9, and it was 31%. And then we used the normal distribution to approximate it. And it was really, really good. I mean, we're off by about 1%. So yeah, what you said is really good. The normal distribution, the normal curve, is a really good approximation for normally distributed data sets. We can use the normal curve instead of the histogram if we want, which is kind of a key point because it's what we're about to do in chapters 9, 10, and 11. We're going to say, hey, we know this data set is normally distributed. So instead of trying to collect tons of data and create histograms and all that, we're going to use the theory and we're going to use the normal curve distribution to do our approximate calculations. So I'm going to pause and I'm going to give you how much time? I think 5 minutes, maybe a little more, to do all of these. And note you're using the normal calculator and you're just dumping the pictures in here. And I want to see if you all can get this. All right, so 5 minutes. Does everyone know what you're doing though? I should make sure you're clear what's going to happen. Someone tell me.
We're just using the mean and the standard deviation we already have. We're giving 4 decimal places and we're putting this in there with the X, blah, 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 415, calculate and transfer it over. Are we doing the picture or no, we're just interpreting?
Picture each time and then maybe you have to interpret. So remember that as you click between these, as long as you don't close out of the calculator, your mean and standard deviation that you typed in there are going to be there already. So you shouldn't have to retype that ever. Awesome. Go at it. Set a timer for 5 minutes.
5 minutes, counting down.
Oh, thank you. Okay, that was 5 minutes. Are we good, or do y'all need a little more time?
I'm slowly getting there. I have all my graphs. I'm just interpreting them. And you said that we didn't have to do both. We can do probability or
Proportion, yeah.
proportion. Yeah, the other P. Okay.
Nice. Yeah. Okay, let's do 5 more minutes. I'll paste in graphs while you all keep working. Set a timer for 5 minutes.
5 minutes, starting now.
So I did something wrong. I'm watching you, and my graph doesn't look like yours.
Same.
So 5, what one is that? I have you on a half a screen, so. Yeah, my 20 is on the other end than yours. Dang it, I thought I had it.
You're muted.
Okay, thank you. All right. So for C, well, first let's double check. Did everyone get A correct?
Yes.
Awesome.
No.
Did you note this? And does your graph have this on it? Yes, no, maybe so.
What do we do? Is that the interpret in the context of the situation part of it?
No, so that is, what does this number mean? This 0.2829. So there are 2 interpretations for this. I'll write both of them, and you all decide if you like them. So the order that we've been doing them is, the first one was always proportion, the second one was always probability. Doesn't matter. It's just I'm keeping the same order. So this we can convert to a percent. And that would be, in terms of proportion, 28.29% of all home runs in 2017 were above 415, what are these, meters, feet, hours? Let's see, does it tell us? Distance, it does not tell us. Did it tell us in the prompt up here what the units were on these things? Doesn't tell us. We don't know. What is this? I'm gonna
I
guess
think
feet.
it's usually feet, I
I
think.
think they're feet, yeah.
Yeah.
That seems reasonable. We're above 415 feet. Okay, so that's looking at all of them, right? Every single home run, 28% of them are above the 415. The other one is, I like saying it this way, but this is different than what you all have probably been saying. There is a, get ready, 28.29% chance of randomly selecting one keyword home run that is, let's say, longer than 415 feet. I think what we've been saying, the probability of randomly, okay, maybe I should just do that. I should do what I know is better. Okay, the probability of randomly selecting a home run. Remember, this means one home run. So randomly selecting a home run that is longer than or further than or whatever the greater than 415 feet is, and you can do the 0.2829, you could do the 29% or 28%, you can write that number whatever way you want, because the probability is a percent, a fraction, or a decimal, as long as it's between 0 and 1. Does that, how do y'all feel about that? Is that okay? It turns out you can copy and paste either one of these sentences for every single interpret question, because the context is the same. Well, I guess you have to use the word between here. And then you don't have to do these. Okay, so that's the interpreting. Let me pause there. Any questions, any thoughts, any concerns, comments, confusions?
I got through that one. I figured it out. I didn't switch the greater than, less than.
I just have a question for C.
Okay, let's talk about C then.
I just didn't know which way to put my greater than, less than sign.
So find the word in C that tells us which way to do it, because there is a word there.
Oh, smaller.
Nailed it. Yes, good. Right. So we're always going to tell you which direction. It's always going to be there. You just have to find it. So any word that is a synonym of smaller is going to be less than. And any word that is a synonym of larger or greater than or something of that nature is going to be a greater than symbol. I think, correct me if I'm wrong, I think there's a list of commonly used words on page something like 265. Fail. 266, yes. On 266, here's a list of phrases. We used it back in chapter 6, but these words, whether they're in terms of a binomial probability experiment or a normal one, they're going to match these words. Just remember that with continuous, we don't care, we don't make a difference between less than or equal to, because the equal to doesn't add anything to it. So Kayla, you only need to write one of the interpretations because it just says interpret. So as long as you do one, you're good. If you want to do both for practice, great. Will it get you extra credit? Sure, I'll give you 0 extra credit. You don't do extra credit, so no, it won't get you extra credit. Cool, so that's C, that's how that picture is. Did you all get D?
No.
Yes.
So why did I do it on the right side? What word told me the right side? As opposed to the left side area.
Long.
Nailed it, long. Okay, wait, what's the adjective? Wait, is it an adjective that describes adjectives, or is it an adverb that describes adjectives? I think this is an adverb, right? Aren't adverbs usually ending in ly? I don't know, that's old school. What does this word tell us?
The 2 standard deviations away, or the 5%, less than 5%.
Okay, so why is 2 standard deviations away useful? Excellent, sorry, ready, yes, crushed it. Why is the 2 standard deviations away useless in this context? Or maybe a better question is, why do we have to use the 5%?
I don't know.
That's really a good answer because we don't know.
That's it. Yeah. Yeah. So unusually, when we say less than 5%, what's that percent? What is this?
Unusual.
Good. But what is it in relationship to this thing? I'll start writing a string of symbols and you all get excited about it. Let's see, percent is equal to probability is equal to area. Yeah, which is also proportion, which percent is a proportion. So this word told us 5%. Now we have to think carefully here. Should it be 5%? Or should it be 2.5%? What do y'all think? Let's just take a trip down 1,000 years ago lane when we were in chapter 3. Oh, here we're learning about standard deviation. Oh, do you remember when standard deviation was so difficult? Rule of thumb. Anything beyond 2 standard deviation, blah, 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 is unusual. Any values with a less than 5% probability are considered to be unusual. I mean, maybe I'm splitting hairs here and we should just be happy with the 5%. Here's the empirical rule. How much area is above 2 standard deviations? And how much area is below 2 standard deviations?
So we have to add the 2.35 plus the 0.15.
And what do we get?
2.5.
Good. Okay.
So we have to do that twice for this answer, like the for long, so it's just the upper one.
Yeah. So do you see why I paused and said, and Laura, we'll go back to C for sure. Do you see why I paused and said, oops, I think I got the wrong answer because 5% is wrong? Because when we talk about 2 standard deviations away from the mean, the total amount of area above 2 standard deviations is 2.5%. The total area below is 2.5%. So that area, that percentage of unusually gets split between the top and the bottom. So for our project, when we get here, unusually long means means the upper end. So to get that right, to be actually above 2 standard deviations, we need this to be 2.5. So let me delete this awful thing. Look at all that cool picture. Let's go back here. We want our greater than symbol, and we want this to be 0.25. Compute. By the way, if we want to see where the 2 standard deviations mark is, it's like right there. See how that's right on the 0.25. I clicked these tick mark things here.
Is
How
it
we doing?
0.025? It's not 0.25.
Yes. Yeah, it's 0.025. I'm sorry, I was saying the wrong thing, wasn't I? All right, how we doing? Do we feel like we understand that a little bit, or is it still kind of
This
crazy?
clicking back and forth is stressing me out. I'm not gonna lie. I can't keep up.
Where are you behind at? And I asked that to know where I should go back and go super slow.
I couldn't figure out how to get back and unmute myself just like I just did because I forgot I was muted. And
You just got muted again. Laura, I'm so happy to wait and get you caught up. So if you need
I'm
to,
so frustrated trying to go
Take-
back and forth.
yeah. So just, I'm so happy to help you go back and forth. So take a deep breath, like a cleansing breath. You all ever done that before? It's like, one more time. In through the nostrils, out through the mouth. Is that helping at all? Might be making it worse.
I'm just trying to stay caught up and I'm having a really
So-
hard time clicking back and forth.
I'm with you.
Sorry, everybody.
You're okay.
Don't be sorry, girl. You are not alone.
We're all
I'm just
going.
having a hard time keeping up because I have Word open, I have StatCrunch open, but then I can't see what you're doing, and then I can't figure out how to get back and unmute myself fast enough before you're on to like 6 problems later.
So let's start at question D. And I'm in Word. And I want to ask you first, are you happy with the 2.5%?
So what number is that? 5?
Let me make sure I know. Let me make sure I'm on the right spot. Yes, 5D, the very last question in the Word document.
Yes, I stopped doing everything else and I managed to get that, but I
So
didn't write
you're
it.
happy with, oh, wait, so you have all of D done.
Yes, I have D done. I didn't
Okay, let's go back to C.
write anything on it though,
Oh.
but
The only thing you need to do is paste the picture on here.
okay, I did that.
So the answer we were looking for D is 450 feet. That's an unusually long, or the cutoff part for unusually long distances for home runs.
Okay.
Now, let's go back to C. So we noted, well, don't look at this picture, gives away the excitement. We noted that we had an area of 20%, which really means we're going to use an area of 0.2. Are we all happy with that?
Yes.
Then we noted the word smaller, which told us where that area was.
Well, shouldn't that be 0.02? Because it's,
Well, 20% as a decimal is 0.2. If it was 2%, then it would be 0.02.
oh, right. Okay.
Good question. Yeah. So let me do what I should have been doing all along with this problem, is to write it out. So what we're really asked to do is find the probability that some X value is less than that particular number. That's what we're finding. And that's going to be equal to 0.2. How are we doing? How's everyone doing? I'm happy for you all to chime in. Laura, thank you for having the courage to tell me where you're at. I'm so happy to slow down and not go crazy. I play video games, right? So I'm used to like clicking around super fast. This is a fun video game.
So since I closed out StatCrunch, I don't have that mean and standard deviation again.
I got you. You tell me when you're ready for it and I'll read it to you.
I have it split right now between StatCrunch and you, so.
Okay, here it comes. 5, 4, 3, there it is.
Okay. And then X greater than or less than.
Go right down to that. Where are you?
We had,
So we had less than because of the word smaller, and then our point or 0.2. Oh, come on now.
okay, all right.
Okay, so in StatCrunch, then I've got my less than, and then I'm putting in the 0.2, and then I'm clicking compute, and there's my nice graph. Now, based on like how wide or whatever, your graph will look a little different, so don't fret about that.
Okay.
And then we go to options, copy it, right click on that copy thing and copy image, dump it in there.
Okay.
Shoot. And that's actually all we had to do for this one as well. We just had to find X, and we found it by this 378. Like it's this is the number. This, why will this not do what I want? Here we go. This is the number that is the answer to the problem. So you don't actually have to write anything because it's right there in the picture.
Okay. And then I had got to do the between one too. I was working on that.
Oh, nice. Okay.
So
This one, you do have to type something into it. You have to tell the interpretation of it.
so it's 390 and 430. Sorry, everybody. Sorry, I'm not sorry.
Hey, Laura, remember about everyone else would love to see this too. So you did people a favor.
Okay. So now I just got to interpret that. Interpret the value in the context of the situation.
And so you're writing a sentence like this. And instead of saying above, you're going to say between, and you're going to write the two numbers. So the sentence itself is exactly the same. Oh, well, I mean, you got to change the area amount, which is what? 0.5326 or whatever you want there. Awesome. How's everyone else doing? Anyone have a question? Or are we ready to jump into the Chapter 7 review?
I'm ready.
Okay. So I'm going to go there to the Chapter 7 review, and we'll get us started. And I'm going to give you some time. Really, I just want you to do the whole review, start to finish. But we can do our thing. We're like 5 minutes. So we'll do 5 minutes on the first page and all the rest. But I don't want to overwhelm anyone. Laura, how you doing? You got what you need for the project?
Yeah, I think so. I was just scrolling up to make sure I got everything. Thank you.
Nice. You're welcome. Okay, so we're switching gears to page 631. Keep StatCrunch open because you're going to be using it on page 632 and 633 and 634, and hey, that's the last page. And I think you're going to find that what we just did in the project is very similar to what you're doing here on Chapter 7. So we'll do 5 minutes for the first page. And you all see where you can get on that, and then we'll check in on what you've done, and we'll keep going that way. And then Chapter 7 will be done. Did you all just want to take the final exam? Should we? That's terrible. Okay. Set a timer for 5 minutes. All right, that was 5 minutes. You all feel like you got good answers for this first page? As in, what did you say for number 1?
I said no,
And why not?
because it's not a straight line.
I said no, the normal probability plot is not approximately linear.
Nailed it. So I want to hear that, Laura, you're right, but I want to hear that you recognize what kind of graph this is. So that means I want you to write no, the normal probability plot, because I want to know that you can distinguish between a normal probability plot, a just plain old scatter plot of 2 variables, and a residual plot. So no, the normal probability plot is not approximately linear. I would put this sentence in your reference sheet just in case I ask it on a final exam. Cool, good, y'all. Love it. And I agree that this isn't approximately linear, it looks logarithmic. Okay, which of these graphs has the largest mean?
I said C because it was furthest to the right.
Good. Remember, this is like scaled 1, 2, 3. So this mean, which is here, is the largest. Awesome. Smallest standard deviation.
I said A because the curve is tall and narrow.
Yeah, I said A because it has like the least spread.
Good. So I wrote down the wrong answer because I wrote the largest one. So yeah, A has the least spread because its shape is the tallest and narrowest. Excellent. Good, y'all. Okay. So this page is done in StatCrunch. Quick question. When you glance at this, are we working with a standard normal curve or just a plain old normal curve?
It says the standard normal curve.
Okay, good, good. All right.
So we
Yes.
don't have to change anything.
Right. And what do you mean by that? In other words, what's the mean and the standard deviation?
0, 1.
Okay, go nuts, y'all. See you on the other side. Set a timer for 5 minutes. That was 5 minutes. Anyone need more time to get these done, or do you feel like you got them?
Let's review it and see if I got it, I suppose.
Love it. Let's do it. Okay. So I'm just going to go into a nice clean StatCrunch deal. And we are doing everything in the normal calculator. 0 and 1. This says probability Z is above 1. So I think we found it helpful, or some people found it helpful, to write this out.
Yes, very much so.
Good. So here's our answer. 0.1711. That's B, or A, sorry. B, percentile rank. That's a less than symbol because percentile is the upper bound. So it's at or below that particular value. So here's this one. Technically, it should also be equal to, because that's included, but it doesn't really bear into our calculation here. Ooh, this one surprised me, 0.9842. But remember, percentile rank is always rounded to the nearest percent. So our answer here is the 98th percentile. Let me pause there because students often forget that tiny little bit. Do y'all feel good about that?
I keep putting my greater than or less than backwards. The wrong way.
Let's see. Y'all like Pac-Man? That is less than. That is greater than. We read left to right. I don't know if that's helpful. I don't know if that's what the challenge was either, Laura.
I get them mixed up because less than is actually facing where if you read from left to right, the number would be higher on the right than it would be on the left when you're looking at a graph. That's why I keep getting them mixed up.
Got it. Well, now you've identified why you're getting it mixed up. Now you won't, right?
Hopefully.
I mean, that's usually the first part. At least that's what my therapist says. You got to start with understanding what's the problem, and then got to name it, and then you can overcome it, I guess. I don't know. Okay. Oops. Why did I put X? This should be a Z. This is what we're looking for that symmetric middle. So it's a between. Let me make it clean there. What's in between? Oh, come on. And our answer here, I'm not going to do what I did to everyone last night or the other night, was writing plus or minus and blowing everyone away because I didn't realize we hadn't done that before. I'm going to write them separately. There's our two answers. And y'all, I'm just going to keep going until you stop me because I'm hoping what you're doing now is checking your answers. I mean, I'm assuming that's what you're doing. So if you got something wrong and don't know why, shout at me. Okay, Z score that corresponds to quartile 3. Here's what I think through. Oh, Q3, that's actually P75 because a quartile is actually a percentile. So by the way, I haven't been shading these because they're over here. So what I'm really working with is being told my area is 0.75. What's the Z score? I know it's a less than, and we're looking at it equaling this. So that was a lot. Hopefully you're feeling good about all that stuff you had to put together and that you got the answer that can be confusing because that looks like area, but it's not. It's 0.6745.
Is the Z score always a less than? Did I miss that somewhere?
A quartile is always a less than.
Okay.
And really more generally speaking, a percentile. So a quartile is a special type of percentile, just like standard normal is a special type of normal. So that's a good thing to keep track of. These mean the same thing, and they always mean less than for area. Cool. How do we all feel? Did you get 100% on those, or did you get something else?
Once I got the way it needs to face right, I got it. I just didn't shade them in yet.
Yeah. Don't worry too much about that. You could just copy and paste this. I mean, whatever. Good. Okay. This one's a little bit tricky because it's not just straightforward what's what. But I will just do a few options. Or do you all need time to do this problem?
I need time to do it.
Okay,
I
perfect.
didn't do it yet either.
So timer for 5 minutes. All right, take 5 minutes and see what you can do.
I think I got it.
I think I got it too.
Okay, that's 2 out of 6. All right, we'll go through it. Let's do it. Turn off the timer. Okay, so I'm going to find this area first by doing z greater than 1.237. The order I do these things doesn't matter, right? As long as we all get the same answers. So there's like 2 options of how you could start this. There's one, you have to, like, we can't find area 1 without finding area 3 or z1, and it doesn't matter what order you find them. It is what it is. Okay, so I'm typing in 1.237, computing, and I get 0.108. At this point, I could do all kinds of different things to get these other different areas. I can just use my calculator and put the 0.847 with the 0.08, add those two together. So that's all of this area, and then subtract that from 1 to get the lower area, which is 0.045. Or I could find this z-score by using the between area, leaving the lower bound value blank, putting in the upper bound value, and then the between area. Oops, so don't put in that. Whoops. I forgot to put in this number, 1.237. Delete that. Put in the between area. So 1.69, negative 1.6959. So maybe we'll do 3 decimals, 6. I could also do a less than, or no, sorry, a greater than to calculate this and put together these two areas, which is what I had in my calculator that I closed already. That was the 0.847 plus 0.108. So there's the 1.696. It's a little bit off because this was rounded. And then I could also use the less than with the 1.6953977 or this z-score to get that area. All right. Those are a bunch of different ways to get these 3 answers. And it doesn't matter which way you used, just that you got these 3 answers. Is everyone good with that?
I finally did something right today. It's the first time I've been able to get that. Thank God.
That means it's
Woo!
clicking. Yes. Whew. That feels good. Let's celebrate with 10 push-ups. Okay, if there's no questions, we still have 24 minutes and we only have 2 questions left. Quick note, is this a standard normal or just normal distribution? And how do you know?
We have to change the mean and everything because it told us what it is.
Good. It just says it's normally distributed and it says here's a mean of this, here's a standard deviation of this. Awesome. We'll do 5 minutes, see if you can do this. And then this time, y'all, you do have to do both interpretations. Sorry. How we doing?
Ready.
All right, let's do it. Let's see. I'm gonna find this X value first. And so I'm gonna use a less than area, and I'm gonna do 0.518 and compute, and I'm getting 23.223. How many decimals do we have to do? 3. Excuse me. So 23.222. Awesome. Let's see what's next. Oh, I'll get that upper area because we know that z-score. So I'll do a greater than, or that, sorry, that x value. So there's my upper area, 0.0595. Oh, we're supposed to do 3 decimal places, right? So let's just delete that last number. Shoop. And then I guess I'll do between, and I'll do the 23.222 and the 27.310. And I'll get the, oh, well, that's not right because I have a negative there, right? So I gotta make that positive. There we go, compute. 0.423. Everyone happy?
No, but is your mean correct?
Yeah, I didn't get the same answers as you either.
Well, the good news is that my mean is wrong. So all of my answers are wrong. That feels really good. Okay, good. Well, thank you for telling me I'm wrong. I want to be all snide and be like, thank you for telling me I'm wrong after I did all of them, but it's my fault, not your fault, right? That's like trying to shift blame. Okay, so here goes again. This time we're going to get it right. Did you have 23.322?
Yes.
Nice. Okay. Yeah. See, look, you beat the teacher. That's gotta feel good. Not that it was a competition, but you know. Let's see. Then I'm gonna do the same thing greater than 27.310, 0.064, and then I'll do the between with that and 23.322. Compute 0.418. Awesome. Did y'all get it?
Yep.
Okay. Did you say that 6.4% of all and probability select 1 is 0.064 and that they're drinking more than 27.310 gallons annually?
I put the wrong numbers in. I did the area A1 instead of A3 and X2.
Gotcha. No worries. So it's just because as long as your interpretation of those was good, then you're fine, although you were supposed to use this one with this area. So what the point here is that because this is the area we're working with, we need the more than or greater than language. And this happens to be the area that's associated with this many gallons of water that they drink annually. Anyone have any questions on that, or should we go to the last page? I think we can do this. I'm going to give you 5 minutes on this one. Note, here's the mean, here's the standard deviation. I will get mine typed in right now so they're not wrong. You all get that, and then we'll have done it all today. Whew. Set a timer for 5 minutes. it's 5 minutes. How we doing? We're like basically out of time, so I'm just gonna smash down the answers, like the probabilities, the calculator part, which is probably the part that you don't really need any help with, just to make sure you got them right. So you should have gotten 0.1035. And 638,097, 837,702. Ooh, more than with a 0.2, so that's greater than, and 0.2, you should have gotten 796, 536. Are those the numbers you all got from your calculator?
Can you go over how you did B, please?
B? Yeah. So B says the symmetric middle. So if I were to write it symbolically, we'd be doing this sort of thing. So what I did is I went to the between. I put in my 0.848 and clicked my compute, and out it spat that. Does that make sense? Is that good?
Yeah, I started to like try and find the gray area and like 1 minus whatever, but that just doesn't matter. So
You could have done that. So if you did the
could have
1
done
minus,
yeah.
What'd you get? What, 0.152?
yeah, and then divided by 2 for each of them.
Nice. I can't do that in my head. What'd you get?
0.076.
Sounds great. It's not what I was going to answer. Okay, awesome. And then you could have done less than, and a greater than, and you should have gotten the same thing,
Okay. Okay.
or roughly the same thing.
Got it.
Yeah, there it is for the greater than. It's got some decimals, but whatever.
Yeah.
And the less than. Awesome. That's a little more work. So this one
Right. Yeah.
slightly, but totally fine. Totally fine. Any other ones you all? We got a solid 6 minutes. Any other ones you all think we should talk about? In terms of interpretation, what you're randomly selecting is a day from 2018. This is the average daily jail population. So here we're saying, like, if we use the proportion one, 10.35% of all days in 2018 had an average daily jail population less than 650,000 inmates. It's one way to say that one. Or over here, 84.8% of all days. Well, actually, if we do what we're supposed to, we would say 15.2% of all days had an average daily jail population below 638,097 or above 837,702. So either one. Okay, what we didn't do today, which I'm not particularly worried about, is the 1-4 worksheet number 2. How do you feel about this being your homework? It's not super important, but it's good to kind of keep in mind these 5 different types of sampling. So maybe see if you can't do this page, and then we'll talk about it on Monday.
We can, Eric, if they want to do it, they can check with me tomorrow.
Nice.
You want to? I should have
works.
time.
And we can also just throw it away, but I'm hesitant to do that because I don't want to mess with people's what we've already said is due. And it's not terrible practice.
And that
So-
worksheet is in both of your guys's class. Like,
Yeah, it's a different one. I did 1.4 worksheet 1. So it is a little bit different.
but on my dashboard, I'm looking at it right now. It says that for the 033 and the 133, 1.4 worksheet 2. It's in both of the classes.
Awesome. 2 for 1.
Mhm.
Well, then maybe we did the wrong one yesterday.
No, I think I turned that one in, and that was supposed to be in your class, Cindy, I'm pretty sure.
Oh, okay.
I know it's in mine. Here, we'll glance in one of these and just see.
I might have originally had it in the 033. I think she might have had it in there, but then I removed it, but I might have not removed it from assignments. I don't know.
Right. That old
But
mess.
it's supposed to be for the intro.
No, put it in the worksheet 2. You'll only see a spot to be able to submit it for
Here, yeah, it's still in here. How about I delete it for you?
delete it.
Shoop. Okay. Hello. Oh, we froze. Yes, there we go. That'll fix it. So now it's not in both in the dashboards.
Just say okay.
Oh, I couldn't see that up there. Oops. Okay.
There you go.
Hit all my other little thingies up there. See which one is this. Awesome, y'all. So we are getting really close to the end of the semester. There are really only 2 topics left to learn: confidence intervals and hypothesis testing. Chapter 8 is the foundation to do those. Chapter 9, we do confidence intervals. Chapter 10, we do hypothesis testing. Chapter 11, we redo both concepts in terms of 2 variable data sets. So for the end of the semester, there's really only 2 things we're learning: confidence intervals and hypothesis tests. So here it is.
No, but it is. I don't know why it's in there.
Yeah. And it's due October. Yeah, whatever. So hang in there. If you're getting stressed, we're making it to the end. These 2 concepts are involved, but we give you a script to work through them. And if you do enough practice problems over them, you will be just fine. It might even feel easier than the midterm, because it's not 1,000 different things you have to keep track of. It's 2 concepts with a bunch of little bits in there, but it's all listed in the script. So in some ways, this is easier. It's more difficult if you don't put in the time to practice the problems. Like, I would argue it's impossible without the practice, whereas the midterm, some of that stuff you may have seen before, you might kind of be able to do it without practice. So it's 1 o'clock. I gotta go. You all have a great evening and weekend.
I'll
And
see you tomorrow, and I'll see you tonight, Eric.
sounds good.
Have a good day.
Bye,
Bye.
everyone.